I recently added a window air conditioner to an upstairs bedroom to provide some auxiliary cooling. Now, since this is in a bedroom, it really only needs to run at night, so we want to find a way to automate it. Now, while this particular air conditioner does come with built-in Wi-Fi, it does require installing a manufacturer's app on your phone and using a cloud service. And we like to have everything local and not rely on the cloud. So we want to see if we can find a way to automate this without using the cloud or the manufacturer's app. Fortunately, this does come with an IR remote. So we're going to see if we can build an IR remote to be able to control this thing through Home Assistant, and then we'll also add a bed sensor to help in that automation. So hang around. Hi, and welcome to Resin Chem Tech. In today's video, I'm actually going to be building two separate devices. Now, while I'm using these devices together to automate my air conditioning unit, note that you can use these independently in your own projects. You can use an IR transmitter to integrate basically any IR device into Home Assistant. And of course, a bed occupancy sensor can be used for all sorts of automations. But because there are multiple parts, be sure to use the timeline here or the links down in the video description to jump ahead to a particular part if that's what interests you. Also note that the video description will have a link to a written guide that will have a complete parts list, wiring diagrams, all the ESPHome and my Home Assistant automation code, and more. So check that out after the video. With that, let's get started. Fortunately, as I mentioned, my AC unit came with an IR remote that gave access to nearly all the features of the AC unit. So I thought if I could build an IR transmitter, I could use Home Assistant to send those codes to the AC unit and thereby automate it. These are the only parts we're going to need for the IR transmitter. Of course, we're going to need our IR LED. I opted to use an ESP32 Mini. The ESP32 has a little bit better performance with the transmitter, but you could use a D1 Mini ESP8266 probably with no issues. Going to need a 5-volt power supply to power our board. I happen to be using one of these Slims. I like them because they have dual USB and they don't block your other outlet when they're plugged in. Need a micro USB cable. I'm going to mount this onto an Electro Cookie prototype board. And there's one other part here that if you've done any LED projects, you've seen in my LED videos, you'll recognize this as a logic level shifter. Now this is optional, but I did find during my range testing that by boosting the 3.3 volt signal from the ESP to the 5 volts before going to the LED actually did help my range a little bit, but that really is entirely optional and you could probably get away without it. Note that you can also add an optional IR receiver that can have multiple purposes depending on the particular model of air conditioner. It may or may not support being able to read the existing remote and updating Home Assistant, but you can also always use this to read the codes from the existing remote and then use those codes in your ESPHome to send those values back out through the IR transmitter. In my particular case, I'm not going to be using the IR receiver, but you can see more about how to wire it and hook it up in the related blog article. And speaking of range, I did actually test a couple of different options, partially because I was having an issue without getting any IR transmission at first. And it's kind of hard to troubleshoot that because you can't see anything from the LEDs with your bare eye. But if you use a cell phone camera, you can see when these are or are not transmitting. It was resolved by using a different GPIO pin. I talk about that in the blog. But in my testing, I did find this KY005 actually had the best range, almost double the range of this particular version when used with the logic level shifter. This third option I didn't try, but it is an interesting idea. It's got both the IR transmitter and receiver on board with an ESP8265, which will work with ESPHome. But this is kind of an all-in-one option that you wouldn't need a separate ESP8266 or ESP32. It is a little bit trickier to use because you do have to flash your ESPHome code using a USB to TTL adapter and the RX and TX pins here on the board. So I did not test that one, but it is an interesting option that might work just fine for you. This is the final breadboard version using the ESP32 and the other GPIO pin, and this all seems to be working pretty well in my particular case. Again, I am running the signal through a logic level shifter. I don't know if that's really necessary or whether it really makes any difference, but it isn't hurting anything. And I am getting anywhere between 6 and 8 foot range off of this. It might even be further, but that is coming at about a 45-degree angle instead of directly in front of the air conditioner, and it still seems to work fine. Now the wiring on this is really simple, so I won't go into a lot of detail. If you're not using a logic level shifter, it's 5 volts and ground and a data line from a single GPIO pin on your ESP controller. That's all there is to it. Again, I'm adding the logic level shifter. Whether it really helps or not, again, I don't know. But you can find a complete wiring diagram for this. Check down in the video description. Now, the one thing is, by adding a logic level shifter, it does mean I'm going to have to move up from this smaller size, which I planned on using, to a little bit larger size of the electro cookie board. But that's okay, because I actually plan on having this in its own enclosure, wired out separate, just in my particular situation. So I'll be able to take my controller box, mount it hidden, and then just run this particular piece up where it's visible and pointing at the AC unit. Now, there's one other thing I should mention. Again, the climate card and climate control and Home Assistant also accepts a sensor, which gives you the current room temperature. I'm obviously not going to be able to get that from the air conditioner, but I already happen to have a DHT22 connected to a D1 Mini in the bedroom that gives me the current temperature and humidity. So I'll be able to use the temperature on that as my sensor for my climate card in Home Assistant. So let's talk briefly about the ESPHome code that's going to make this work. Fortunately, ESPHome already has an IR remote climate platform, which is really built for controlling AC units via IR. And really, fortunately for me, if I come down here, my Medea air conditioner actually has its own platform, which means it'll have all the codes built in to control many of the features of the IR remote that came with the unit. I won't even have to learn any codes and use any kind of IR receiver. Now, the code is really relatively simple. Just need to create a remote transmitter, which again could be used for a lot of other things besides air conditioners to control other IR devices, and then I'm going to add a climate platform in there as well. And here is a quick look at my ESPHome code. Again, check the video description where you can find copies of this. But I am defining my remote transmitter up here, GPIO pin of 22. That's what I actually had to change. I had issues when I used the original GPIO 32 on that. It may have been a problem with my board. Down here, you can see I'm not using a remote receiver, so I have all this commented out. But if I needed to use a remote receiver to either update from the original remote or to learn the codes, I could actually uncomment this and be able to get any codes received from the original remote in the ESPHome logs. Then I'm adding a simple climate. This will vary somewhat depending upon your model or brand of air conditioner, but then I'm also adding in a sensor to get the current room temperature, and I'm bringing that sensor into the climate control so that you see that in that Home Assistant card in your dashboard. And here's my final version once it's actually mounted on the electro cookie board. I did 3D print an enclosure for that. You don't have to have a 3D printer. You can find small electronic project boxes that you can easily use as well. I did opt to keep my IR transmitter out here separately, just because where I wanted to mount that in my bedroom. And I did 3D print a little wedge to hold that and added a little bit of braided cable and some heat shrink wrap just to make things look a little neater. So this is where I decided to install that IR transmitter. And part of the reason I didn't install it on the board is because I could have this small little piece exposed. And if we spin around here, you can see that that's pointed really right at the AC unit. And the distance is about 6 feet. And by having the IR transmitter separate, it also allowed me to take the much larger controller box and tuck that back away into the back of this stand. And as you can see, once we have this fully integrated into Home Assistant, we have control, the ability to turn the AC off and on. We can actually change the temperature set point. And we have control over fan speed, power modes, and more. But again, having full control in Home Assistant, which now means we can automate it, including turning the unit off and on. So the IR transmitter alone is enough to do an awful lot of automation with this AC unit. But I wanted a little bit more control and wanted to add something I've wanted for a long time. That's a bed occupancy sensor. So that's what the next part of this video is going to cover. Now, there are many different ways that you could build a bed occupancy sensor. You could use load cells underneath the legs of the bed. You could use a pressure mat. You could even use something like a contact switch. But I ran across a forum post in one of the Home Assistant forums from someone named Tom L., who was using a force-sensitive resistor. And it looked like an interesting idea, so that's the method I decided to use, but this is by no means the only way. These are the primary parts I'll be using for the bed sensor. Of course, we've got our force-sensitive resistor strip here, and after a little bit of testing, I decided I'm going to go with the Wemos D1 Mini, the ESP8266. I only need one analog input pin. Now, this strip is only about 24 inches long, so if you wanted a sensor for each side of a larger bed, like a queen size or larger, you would probably need two of these strips, one on each side, in which case you might want to go with the ESP32 because it has more than one analog input. But since I'm only going to need one for mine, I'm going to go with the D1 Mini. I'm going to need a resistor. Now, this resistor is going to vary depending on your particular situation. I'll talk about that. We're going to need a USB to micro USB cable and a 5-volt wall wart. Now, I happen to like these because they have two USB outputs, so I could either run two controllers or use the second one to charge a phone or whatever. They do handle up to 3 amps, so they will run a couple of basic controllers with no problem. Now, I am putting this on the larger electro cookie board. It would easily fit on one of these smaller ones. The reason why I'm using the larger one is, after thinking about it, it seems like just using one single analog pin on this is kind of a waste. So I'm going to add a few optional components, and these are definitely not required for this project. But I'm going to throw in a couple of push buttons that I could use for automations or enable, disable the bed sensor, however I decide to use those down the road. And I'm going to go ahead and add a logic level shifter here and wire it up, so in case I decide to add something like underbed LEDs as part of this project down the road, I will already have this wired to also be an LED controller. I'm not going to do that from the get-go, but I figured why not go ahead for $1, throw that on there and wire it, and I would have the ability to come back and add LEDs to this at a later time. Now, using the larger electro cookie board does mean that my enclosure is going to be a little bit larger. I've already 3D printed here a prototype, but it will make it a little bit easier to accommodate my buttons versus the smaller size enclosure. This is what I normally use for the smaller electro cookie board. But since this is going to be mounted in a bedroom on the wall between a nightstand and the bed, size really doesn't matter. Just realize what I said. Please, no comments on size doesn't matter in the bedroom. So if you happen not to have a 3D printer, again, as I've recommended, you can buy these small little plastic project boxes on Amazon and elsewhere. And it's pretty easy to drill holes in here for your wiring. So these make good enclosures for things like controllers if you happen not to have a 3D printer. So one of the first things I wanted to do was test this force-sensitive resistor because it was packaged and actually had some crimps in it, and that was a little bit concerning. So I just simply hooked it up to the multimeter here and set it to ohms for resistance. And I'm just going to apply a little pressure, and sure enough, I'm seeing a change in resistance with the pressure and how hard I press. So that's at least working. And now to get the maximum range for this, when it's actually in the bed, I need to determine what the resistance values are when I'm in bed versus out of bed, and that will help me determine the size of resistor I need to attach to this. So one of the initial challenges here is we need to attach a couple of lead wires to this. Now they do make clips that clip onto this. I prefer to have a soldered connection, but this is extremely heat sensitive, so we need to be a little bit careful with our soldering and use as minimal heat for as shorter time as possible. I've already tinned a couple of my lead wires, so I'm going to go ahead and try to quickly tin these connectors. And again, we will now try to attach these lead wires onto here. Again, trying to use as minimal heat as possible. So now we'll come back and add a little bit of heat shrink tubing to help support this and to make sure that these don't come together and touch. All right, I put a little heat shrink on there, removed those from the clamps, hooked the other ends of our leads here back up to my multimeter, and hopefully we're going to see a different reading, and we do. The harder I press, the less resistance there is, so looks like at least we didn't damage anything with the heat. But now we're going to need to determine what resistor we need to add to this, to get the broadest and most stable range for our sensor. To get your starting resistor value, what you'll want to do is take your strip, go ahead and install it under your mattress temporarily, and hook it up to your multimeter set on ohms. We need to get a starting resistance value with the bed unoccupied versus occupied. So I've got a little bit of weight sitting on here, otherwise it would just be out of range, but your readings will be completely different. But what you want to do is get some resistance readings with the bed unoccupied, and then get into bed, and there's a good possibility you may actually need to change the scale on your multimeter. And you want to take a dozen readings or so of both, of occupied and unoccupied. And we're going to get those, and we're going to kind of average those together to drop into a calculation to get us at least a starting resistor value. So for me, and again, your numbers will be completely different just based on the weight of the mattress, how you are opting to lay when you're in bed. But I had an average resistance of about 3 mega ohm when the bed was unoccupied, and a resistance of about 500 ohm when I was in the bed. That is an average taken over multiple readings. But if we drop that into our calculations, converting everything to kilo ohms, we have about 3,000 kilo ohms times 0.05 kilo ohms. Take the square root of that, and it gives us a starting resistor value of around 38.7 kilo ohms. So that's where we'll start out, and then we'll fine tune that doing a bench test on a breadboard. So once we've calculated the approximate value of the resistor that we're going to need, I set up a little breadboard test, and our two leads here are going off to the force-sensitive resistor strip. Again, since it's just a resistor, positive and negative don't matter. It doesn't matter which terminals you go to. I'm showing the ESPHome code here, a part of it. I'll come back to the full ESPHome code in a little bit. But what we're doing here is we want to measure voltage coming into our analog pin. So we're going to feed 3.3 volts out through our resistor, create a voltage divider into our analog input pin, and this should give us voltages. By setting it up like this, it's easy to swap out this resistor for different values. What we ideally want is we want something in the 3 to 3.3 volt range when the bed is unoccupied, and the biggest drop that we can, preferably down to around 1 or even less than 1 volt when the bed is occupied. So it's pretty easy to do this on a bench test. Get your readings from ESPHome or from Home Assistant in this case to watch that voltage. And it's fine to do this on the bench initially, but you really want to take this and install it in your bed because you're going to have the weight of the mattress, your position of where you're laying. So by doing this on a breadboard, we can take it up, install the strip underneath the bed, try different positions of the strip. I found the strip to be best somewhere around my hips, not up around my shoulders, but you can experiment with that to try to get the broadest range that we can between occupied and unoccupied. This is the final soldered version, and it's pretty much exactly like it was on the breadboard. See, we're coming off our 3.3 volts from our D1 Mini to feed one side of a resistor, creating a voltage divider here that we're going to feed into our analog pin, and we've got our two leads that are going to go out to our force-sensitive resistor strip. So that's really all we need for the bed sensor. But as I mentioned, since I have all this extra space and all these extra pins, I'm going to go ahead and wire in a couple of push buttons that will be on my case that I can use for multiple purposes, whatever I decide to use these for in Home Assistant. And I'm going to go ahead and drop in a logic level shifter and go ahead and wire this up for potential LEDs that I might want to add down the road. I'm not going to add those now, but it'll be wired if I do want to come back and add something like underbed LEDs down the road. So I'm going to go ahead and solder in the buttons and the wiring for the LEDs, and then we'll come back and give this a final bench test before we take it upstairs and install it. Just thought I'd show this now with the optional components that I decided to add on, and again, these are entirely optional. You don't really have to have them. But I did wire a normally open push button to D1 and ground, and another push button to D2 and ground. And underneath here, you can see that I've got the logic level shifter in place, and I have a data line for future LEDs coming off of D5 into my logic level shifter, which is also wired to 3.3 volts and ground on the low voltage side, 5 volts and ground on the high voltage side. If I decide to add LEDs down the road, I'll just need to add a data line and a common ground off of this board to my LED strip. But again, all these push buttons and the logic level shifter are completely optional. You don't really need it for the bed sensor itself. So let's take a look at the ESPHome code here quickly that we're going to load onto our controller because we're going to want to use the values in Home Assistant to do some of our testing. The ESPHome code really is relatively simple. We're going to define a sensor, and again, that's going to be based on that voltage coming in on our analog input pin. I'm applying a couple of filters here. Again, check the written version of this for a little more detail and a copy of this code, but that's really going to give us a voltage level being measured into that analog pin from our force-sensitive resistor. Now, there is an input helper that we're going to create in Home Assistant, and that's going to allow us to set the voltage that is the actual trigger level between occupied and unoccupied. So we're going to import that into our ESPHome code as well. Then finally, we're going to create a binary sensor that when the voltage is below that threshold value, it's going to return true for being occupied and false when it's not. So that's a binary sensor we're going to see in Home Assistant as well. Now, these other ones down here are where I've just added for my push buttons in there. Again, those are optional, but they're a very simple binary sensor on or off, whether the button is pushed or not pushed. That's really all we need for the ESPHome code. So this will be our last bench test. A couple of things to watch here. The current voltage on this is 3.14 when there's no pressure applied. We apply pressure, the voltage is going to drop. When it drops below our threshold value, then our occupied sensor ought to turn on. So we'll apply a little pressure. We see the voltage is dropping. Once it's below 2, our bed is now occupied. When we remove that pressure, our voltage is going to rise back up. Once it's above the threshold, the bed is now no longer occupied. While we're here, we'll go ahead and test a couple of optional buttons. There is button A. There is button B. Everything is working. We're ready to install. So installing the strip is extremely easy. You just want to come in here and find a flat surface on your bed. Again, I have a Sleep Number bed, so this entire surface is solid. But on a traditional box springs and mattress, you would just want to find a slat. You could install this across. I just added a little bit of tape to hold it down. And I added some optional braided sleeve here just to make things look a little bit neater. We're just going to tape that down in the spot. Again, I'm positioning this somewhere kind of under my hips, under my butt, which is what I found was the best position during my testing. We're going to run that up, and we will eventually just attach the controller to the wall right there near my head. Now it's time for a final test. You'll notice this bed sensor is off because we're above the threshold. As soon as I get into bed, notice the voltage begins to drop. As soon as it drops below the threshold of 1.75 volts, the bed shows it is occupied because the sensor turns on. Now, I tried a number of different positions and rolling around, and the voltage varies some, but it stays well below that threshold of 1.75 volts. As soon as I actually get out of the bed, the voltage is going to rise above our 1.75 threshold, and the bed sensor turns off. So it does seem to be working just fine. On the Home Assistant side, I've just created this quick little dashboard to show both of the devices that we just created. Over here on the left is the bed sensor, and over here on the right is the IR remote. Now, the nice thing is by using ESPHome, all of these entities are automatically integrated for us into Home Assistant. We didn't have to create anything, with one exception, and in my case, I added a second one. The first one is this input number helper for the bed trigger level. Remember, we're using that to set the voltage that we want between occupied and unoccupied, and it makes it easily to adjust this if things would change with the bed in terms of the weight. The other thing that I added was an input boolean helper or a toggle, and that's just for my automations. It gives me the ability to turn on or off all of the automations related to the air conditioner. So I might want to turn this off, say for example, if I'm traveling or some other reason where I want manual control of the air conditioner. By toggling this off, none of my automations will run. I can toggle it back on and all of my normal automations will run. On the IR remote side, again, you see we have full control of everything that the original remote offered, including the power, fan speed, mode, the ability to set the target temperature, and more. This gives us all sorts of flexibility in terms of creating automations in Home Assistant to control our AC unit. I'm not going to spend a lot of time here on the automations, and again, I'm showing YAML. Just note that these same automations could be created using the Home Assistant UI automation editor, and there are a lot of different ways to do it, but just to give you an idea, here are the automations that I'm using. So to turn on my air conditioner automatically, I'm going to check at 9:30 every evening. Then I'm going to check a couple of conditions. First, I want to make sure that my automations are enabled, so I'm going to check that input boolean to make sure it's set to auto run. Then I'm going to check the room temperature. If the room temperature is above 69, then I'm going to go ahead and take the action of using my IR transmitter to send the code to the AC unit to turn it on and set it to a mode of cool. Now, to turn the air conditioner off, I'm going to use that bed occupancy sensor. I'm going to watch the bed occupancy sensor when it goes from on to off, meaning the bed has went from occupied to unoccupied, for at least 5 minutes. I'm adding 5 minutes in there in case, those late night, got to get up, get a drink of water, make a trip to the bathroom. As long as it's been unoccupied for 5 minutes, and once again, my automations are enabled. And then I'm also adding a condition of between 6 a.m. and noon. So as long as it's between 6 a.m. and noon and the bed has been unoccupied for at least 5 minutes, then I'm going to use the IR transmitter to send a command to turn the AC unit off. It's really that simple, and there are a lot of other ways that you could use to create automations for the AC unit. So that's pretty much going to do it for this project. After having it run for 2 to 2.5 weeks so far, I've been really happy with the results. But remember, you could use either one of these devices to do a lot of other things with Home Assistant. You can use the IR transmitter to basically integrate any kind of IR device into Home Assistant. And of course, the bed occupancy sensor can be used for all sorts of other automations. And if you found anything in this video that you liked or found helpful, do me a favor and hit that thumbs up button. That lets me know that you'd like to see more videos like this. Hit that subscribe button if you want to see more of my content, and ding that little bell icon if you want to be notified when I release new videos. As always, I'd like to say thank you for watching, and I hope to see you soon.